This is the Amp Hour Podcast. Released August 7th, 2022. Episode 598. Best way to find a leak.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
What's up, nerd?
Not much, nerd. Writing code and trying to avoid the chip shortage and, just the
right,
just the usual
stuff.
2022 kind of thing,
Right. I may or may not be writing code soon. It depends on which way my new project goes. So, in fact, it could go both ways. I could be
code-free or coding.
Could be Schrodinger's code. I'm both, writing code and not
Lock
writing
Dave
code
into a
at the
room
same
with
time.
a keyboard, and until you open the door, you do not know if he is coding or not coding. He exists in both states.
Exactly. Simultaneously, yes.
Yeah. How much are you releasing about what you're going to be working on?
Oh, well, patrons have already seen the video, but after this, I'm going to go reshoot it because it was basically, it's a 50-minute video. We can link it in. It'll now go on my second channel. It's a 50-minute video of me reverse engineering a 10-pin connector. Yeah, the side. Well, there weren't actually that many side tangents. It was all kind of, figuring out what's going on here because it was a rather unusual circuit. If you don't know, did you see that BOM looking gas detector device?
I did see it. Yeah, I watched the video. Yeah, I was expecting it directly after you. So Dave had this thing that looked like a big boomy boom device in his mailbag, and it looked like a landmine or like a water mine. Really.
It looks like an underwater mine. Yeah.
Yeah. Or like it looks like a 1990s like Mario underwater mine because it's got like very 90s teal to it.
I got it.
Yeah, but very intriguing about what it was, and it turned out it was a sonar device, right, or something like that.
No, it was an ultrasonic gas leak detector.
Ultrasonic. That's
and
right.
all those big protrusions coming out that you thought might be like pressure things, so when you press them it explodes or whatever. Yeah. But no, they were just piezo ceramic ultrasonic sensors. And yeah, these are like designed to like sit on top of a pole in like a gas plant or something, which has all the gas pipes and everything running everywhere, right? All that, it's not any plant that has any sort of pressurized gas, right, running through pipes. Because if you get a leak in these pipes, it could be an explosive atmosphere and stuff like that, right? So you want to detect whether or not these pipes are leaking. And apparently, if they get a really small leak in them, you can't hear it, right? Hence it's in the ultrasonic range. So these things are designed to detect from 20 kilohertz up to 100 kilohertz.
Oh, so it's like the like the sound of steam escaping. I thought it was actually detecting the gas.
It's the sound of whatever gas is in there escaping.
Or whatever it is, yeah. But it's like microfracture type stuff.
It's a microfracture, a crack in the pipe, a hole, I don't know, something's happened, right? A seal is, leaky or something like that. And so depending on upon the gas pressure, the type of gas, the temperature, the ambient temperature, the size of the hole and the shape of the hole and everything, you can get anything from an audible, kind of sound up to 100 kilohertz ultrasonic, which you can't hear. And often you can't smell these
Dave's
things.
actually going to do this right now. Ready? 3, 2, 1, go. Oh, wow, that was really good. That was a really good impression. Yeah.
That was ultrasonic. I'm able to.
They say Dave has a squeaky voice. They didn't even know
it
how.
It actually goes up to 100 kilohertz. People don't know this, but
dogs hate him.
Right. The number one hated podcast by dogs. The number one downloaded podcast by dogs.
Jake the dog used to bark a lot actually during recording. So yeah.
Yeah, that was it.
Yeah.
Oh boy. Anyway, so these things just hang up on poles and they go back via an RS485 line to a control center, and then the alarms go off if they detect this gas leakage sound or whatever.
Yeah.
Very cool. And then and it's in a big pressurized vessel. Well, it's not pressurized, but it's designed so that if anything short circuits inside, it doesn't ignite anything outside. So it doesn't escape. Flames don't escape. Nothing escapes. Right. So it can just blow up inside. and absolutely nothing happens. You're not going to blow your entire gas plant up or something like that. So that's why they're
Makes for good
designing
videos,
this
though.
huge, thick steel, round bulbous case and everything. So anyway, and we'll link that in. It's amazing engineering that goes into the mechanical design of this thing, circle wise. Anyway,
I had when I was at ABB, they had a couple products that were like explosion proof, or maybe we were looking at maybe a competitor. I don't even remember, but there's like intrinsically safe like standards, and I never got that far on it, but it was like they're like even like color code. I think they're color yellow, I think, but like circuit boards that are intrinsically safe tested to be, and so that like basically if they go look in a cabinet, they're like, okay, this board itself is not going to cause any kind of spark that would set off. If there was gas in the air, it's still not going to blow up, that sort of thing.
If something happens to it, it can cause it can cause an explosion inside the mine or whatever. So
right.
yeah,
I think it's
so
like assuming there is presence of gas versus like
exactly. But when you're analyzing failure modes like this, you have to assume worst case, right? So you've got to assume that there is a gas leak, and Murphy's going to get you that at the exact same time there's a gas leak, you're going to get a failure inside your product, right? So which will then cause it to ignite. Most of the time there's not a gas leak. It's fine, right? And you can use your $2 cheapy, meter inside a mine, right? But no, otherwise,
I mean, the best way to find a gas leak is to just
light a match. Exactly. So you can buy like a Fluke 87 meter, right? A standard Fluke 87 meter, but it also comes in an intrinsically safe version, which is exactly the same meter, I do believe. Please correct me in the comments down below if I'm wrong. But it's the exact same meter, except it is rated intrinsically safe. So it's gone through the whole certification process. So you can't actually use the standard Fluke 87 multimeter in an intrinsically safe environment. You have to buy the marked intrinsically safe version, which I believe is the same, but it's actually silkscreened on the case that says it's intrinsically safe. Right? So
and also the price is about 3x,
and
3x to 5x.
I'm sure the price is significantly different. So I don't know. Maybe they might do greater production test, and maybe each unit's individually tested instead of batch tested or something. I don't know. If you do work in the intrinsically safe industry,
there's separate certification.
I'm sure there's different levels of intrinsically safe as well. Yeah. So anyway, so you can just buy a standard one.
So you are not building that right now.
I am not building that right now. No, but what I'm doing is taking the LED display on this thing because it looks like a BOMB. Right, it just looks like, and it's got this like 5-digit LED display on it, and I thought, come on, we've got to put a countdown timer on this, right? And then make it, I don't know, tick or something, right? And yep, and then if you try and shake it or something like that, then it actually counts down faster or something,
right? Or like that. There's like a game where it's like hot potato, but like there's actually like a digital version of it or something,
I don't know. But this is every 1980s movie, right? This is like the bomb, and it counts down with 2 seconds left, and you snip the red or black wire.
Yeah, you have to have wires coming out the side too. Yeah, you have to like many colors. Which wire do I cut? I need to know. Tell me. The battery wire.
my favorite one. What's that? Oh, what's the one on the plane?
There are multiples.
There's I know. They're on the plane. Oh, God.
Snakes on a plane?
No, it's not snakes on a plane.
There's Con Air.
It had Steven Seagal, but he lasted 5 minutes. Spoiler alert, before they kill him off.
About the right amount of Steven Seagal.
It was Kurt Russell. It was Kurt Russell, I think.
Executive Decision.
Executive Decision. Thank you. Executive Decision. Yeah, where
Chris
the nerdy guy.
Bad movie titles. Yeah.
Oh God, the nerdy guy. You've got to watch it. Like the nerdy guy.
No spoilers. This is a brand new movie.
Anyway. Okay, all right.
Only 35 years old, right?
I think it's 90s or something. Yeah.
Oh, was it? Yeah.
Executive Decision, maybe early.
So let me ask you. You're saying something in the 90s can't be 35 years old, because I hate to break it to you, buddy.
I know. Okay. I know. Right. Anyway, there's the the nerd has to go on the mission, right? And he gets caught up in it, and he's the one who's got to defuse the bomb, and stuff. Yeah, and he does it. We won't tell you how he does it, but it's just it's cringe, and it's so good. It's so good. so bad, it's good. So
yeah. Yeah,
Yep,
classic.
I love it.
Yeah, 96. 96.
96, there you go. Yep. Yep.
All right, there's your homework for
Cool.
tonight. So this is the thing you're building though. Is going to be that display. That's what you're getting.
I'm starting the project and I don't know where it's going to go. So I'm going to release
Got
part
it. Got it.
one,
Got it.
hopefully today,
Mhm.
and then we'll see what people want. Do they want me to do it as a microcontroller based solution? Because we've already got the LED board, right? We've already got the board with the 5-digit LED display. I've reverse engineered the flat flex interface for it, so we know the pinout and the functionality and how it works. So now we can drive this display because it's already designed and built and it fits in there and it's got a nice little gasket on it and stuff. So it already fits in there nicely. So I don't want to redesign that. So I'm just going to design a board which plugs into it. Now, of course, there's two ways that you can drive this sort of thing. You can do it using a discrete logic solution. So I can have a discrete counter, like a 5-digit counter, and then then latch and shift that because it's a shift register based thing. Spoiler alert. Yeah.
Mhm. Sure.
Right.
Yep.
So you got to
Yep.
shift in the serial data to drive all the 5 digits, right? So I can then latch counters and shift in and do it all in discrete 7/4 series logic, or maybe do it in a PLD or an FPGA or something like that. Or I can do it, of course, in a
No.
microcontroller grown,
Yeah, go
because
with the
that's the
micro.
obvious
Come
way.
on, man.
I
Because then you
would.
can also get like you can get an accelerometer plugged into it. Then you could say when you
Yeah.
shake it,
Yeah, but
it
you can
says
also
like,
do the accelerometer with the discrete logic as well. You can get one with
oh my god.
maybe.
I mean, you sure you can, but you also could expand that project out quite a bit.
Yeah, but I don't want this is not, this is like just for funsies,
Just
right?
for
This isn't
funsies.
for
I know. You're
sale,
right.
right?
It's
This
for
isn't
funsies.
for,
Hey,
people aren't
you
going to
do
be
you,
building
buddy.
this thing.
Whatever you think the right thing is the right thing for the
What do I
project.
think? Whatever the people think is the right decision.
No, the people are wrong. I'm sorry.
The people are wrong. Yeah, they are often wrong. Yeah, I have to agree.
I mean,
Yep.
tried that experiment a couple times, I think.
You're right. Yep. Yeah, it never
And
kind of
also, we
works.
always talk about, like
Yeah.
the design by committee. It's tough.
Right.
That's a
Yep.
tough road. It's a tough road. And
Mm.
yeah,
Yep.
every time I see that with external projects, like obviously you and I talk about it, but whatever. When I see like kind of like open source projects, like it's just always it really is the best intentions, but it's so hard to wrangle people. People are
Mm.
you can divvy up a design maybe, but even still, like you really just got to have
No,
one person
it
that's
never
driving it all
works. It
forward.
always comes down to
Yeah,
one person driving the lot,
yeah,
one
yeah,
person doing everything.
yeah,
Yep,
yep.
totally. I don't care how big the project is. Isn't that the Pareto distribution thing? It's like 80. What is it? 80% of the 20% of the people do 80% of the work or something. It's
Yeah, I
something
mean
like that.
that's like
Yep.
Pareto being applied to work. Yeah,
Yeah. Right.
yep.
So yeah.
Yeah, I think about it like it's almost more like a power distribution where it's like, you look at like contributors on Wikipedia and similar like that. It's just,
Yeah.
there are very, very small numbers overall compared to the number of readers versus even the number of contributors, like that.
Yeah,
Yeah.
it's the
The
same thing on
point
forums
zero
and
zero
stuff
one
like that
percent.
as well.
Yeah,
There's
exactly. Totally.
yep, there's a handful of people who do most of the posting.
Mm-hmm.
Yep.
Yep.
So there you go. So you reckon microcontroller, huh?
How about this? I'm not going to tell you what you should do. I'm going to tell you what I would do. And yes, only because it's, I think, a little faster iteration, maybe less fun.
Totally less fun.
Maybe I'm a little more prone,
Yeah.
maybe more prone to mistakes than you are. But I think that would be less frustrating for me at this stage in my life.
Yeah,
So,
but this is like supposed to be educational. So yeah, I could do this is why I could do both, right? I can do, okay, here's how I would solve this with the microcontroller, but here is also how I would
sure.
solve it with discrete logic. And it actually becomes a nice example of how to design using discrete logic as well. It's
Yeah, yeah.
it's a really nice example.
I
You
do
got
think it's a good, because it's driving individual pins at special timings and stuff like that. Actually, yeah, that is a good. Often people say like, well, what do you even use an FPGA for? Or discrete
right.
logic for? I guess by extension, right? Yeah. So that from that perspective, that makes sense.
Yeah, I think that'd be good. Anyway, I'll put that up maybe as a poll on my YouTube thing. But
Cool.
as you say, yeah, people aren't always right. Like I've done that, and I've done polls. I've done my yearly surveys, and people say I want to see this type of video, so I do this type of video, and nobody watches it. It's like
Totally.
it's yeah, okay,
Yeah.
thanks.
Yep.
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 But yeah,
how
it's hit and
people go.
miss. I don't know. can't trust the people. Just trust yourself. Yep.
Yeah.
All right.
I was actually just today, I was working on refactoring some microcontroller code, and I was working with a mentor, and he was helping me through it and stuff like that. It was basically just like chopping up an example to kind of refactor it into more files to make it a little bit easier to read and stuff like that. And
Yep.
pretty simple kind of concept. But I was talking about it. I was like, this is. I wish that I would have been shown this. I feel like this. I've worked with mentors and other people like that on this kind of thing before as well. But I just feel like refactoring and like being able to like cogently read code and then move it around and shuffle it to different places. Like that's something that I wish I would have learned a lot sooner in my career, because it's
Yep.
like such a time saver, and it makes future Chris so much happier at current Chris, because it's
Yeah.
actually like
Can
that.
you,
It's like,
for those who don't know, can you explain code refactoring?
well, in this case, what I'm talking about is I'm taking an example, and it's like a very, very long example. There's like probably 20 functions, and there's a secondary. So they're in main.c. And so like everything's kind of in main.c for kind of simplicity of this original example that I'm using.
Yeah.
And then I'm like, well, I want to like take this and I want to use this in my project. I want to take this really good example, but I want to make it kind of more testable and more broken out.
Yep.
So then I would only take like two functions, two like C functions that do feature A, and I put that into feature A.c. And then I do the next 5 functions, and those are for feature B, and I put those into feature B.c, right? And that kind of thing. And then, but actually then getting it to rebuild and making it like so that everything's talking to one another, because now you have multiple files.
The first step is to separate it into separate files and then make sure it rebuilds, right?
Make sure
Otherwise you're
totally.
screwed from the get-go. You got to make sure it still works. Yeah.
Right. And you think about like how data hiding works in a lot of like when you have separate files, then sometimes you have, if you think of it in C++ way, usually there's public private, but in C it's more like, is it a global variable, or is it local local only to the file that you're in?
Just
that
make
sort of
everything
thing.
global. She'll be right.
Sure.
It's
Yeah.
easier.
I did channel that perspective today. Maybe it was tried for it.
Yeah, it's just easier sometimes. If you just if you just want to
Sure,
get the job done.
maybe not the best coding practice, and as I've known and also reheard today, but sometimes it helps to get stuff compiling.
Right.
So, but it's been really great to I always say like, so I'm in my late 30s. I'm working with a mentor still. Like it's important, like.
Yep.
I'm not good at code still, and finding people that are is very important to ask for some of their time and get some help. And if you can do that, you're a very lucky person, I think I'm a very lucky person.
Excellent.
So Dave, if you do write a micro and you need some help, find someone else, because I'm not the person for it.
Excellent. I'm good. Plain vanilla C, global variables everywhere. She'll be right, mate. No worries.
Yeah, sure.
Yep.
What would you, if you do go micro, what is your, you gonna go pick? Because you're,
I don't know. Once again, it's up to the peeps. Like I don't want to do the STM32 thing. That's like grown. Like you can't get them, and everyone's doing the stupid ARM thing. So I'd be tempted to go back.
Well, interestingly, you can't get PIC either.
Really?
I think.
Okay.
Oh yeah. Actually, you should be doing that. We talked about the Raspberry Pi 2040, RP2040.
Oh yes, yeah, right. Yes, that could be. I've still got that open in one of my tabs, actually, thinking about a video on that. So there's an interesting thing.
That would actually be kind of an interesting, because it's the combination as well with like the PIO doing the PIO, the programmable IO.
I could try to do I could do shifting in the hardware IO.
Yeah, exactly.
Perfect example. Yes, thanks for reminding me. Yeah,
I forgot about that too.
Yeah. I deliberately I've still got it open because I'm a tab person, right? I just keep shit open in tabs, right, to actually remind me. And the thing is, occasionally I'll like lose all my tabs because I don't know, the browser reset itself or crapped itself or something. And then I'll like, that's like a refresh of like all of my thinking. Like it's, it's
more like a email bankruptcy.
Right. Yeah.
I declare bankruptcy.
So here it is. Yeah, I've still got the tab open for the Raspberry Pi Pico examples for the PWM PIO for doing the assembly, for doing the shifting of the things. Yeah, we talked about that a couple of,
I think we
how many weeks ago
I
was
think we
that? 'Cause
talked
I still
about
got the
a
tab
little
there.
bit on the show, but then you and I
Yep.
talked about it a lot more after we
Oh,
cut
did we?
off.
Okay,
I think.
right.
I think so.
Okay.
Yeah.
Yeah, and that's why I kept the tab open, because I was kind of excited by that, and I thought, oh yeah, I might be able to do a video on that. So I just kept it open as a reminder for me. But yeah, you're right. That could be the example there.
Plus, then you can
Mm.
get a W and you can make it IoT enabled, Dave.
No, I'm not. No, I
Walked right
refuse.
walked right into it, folks.
I
Walked right
refuse
into
to
it.
have an internet-enabled bomb. No, it's just not going to happen. No, on principle, on
On
principle.
principle. He's a
Yep,
man of principles.
yep,
Anyways,
I am.
I did want to bring that up though. There is a teardown of the Pico W, which we talked about 2 weeks ago, I think. But now there's like an Electron update, which does some of the teardowns and
How
die
do you do
shots
a
and stuff like
teardown?
that
Oh, okay, it's a die shot.
of the
Okay, I was
actual
going to say.
module. Yeah,
Right.
yeah,
Okay,
yeah.
right. Cool.
Kind of hard. I mean,
Nice.
like they're pointing out different things here.
Mm.
I don't know. It doesn't really doesn't impact me too much. Like it's like,
Well,
oh look,
no,
it's looking.
it's just out of interest. It's not
Yeah,
useful information. I mean, it's
right.
not.
What's under the hood?
No, it's like, it's just go. Oh, look at the nice die. Excellent.
Mm-hmm.
But
Yep,
yeah,
yep,
no,
yep.
it's not actually useful technical information to store away in
Yeah,
your brain space. So yeah, nah. Anyway,
yeah.
can we talk about dodgy design? Because when
Sure.
spoiler alert, in this reverse engineering of this LED display, you would think, this is
Yeah.
like in a controlled, this is like in this atmosphere where you don't want things to be overloaded, and like
Okay,
anyway.
so just so we're clear, this isn't a third party. This is the one that's actually built in currently
This
that
is
you're
the
then
one
going
that's
to be
built in to the
tacking onto.
Banshee brand
Got it.
ultrasonic gas leak detector, right? So I'm reverse engineering this thing. It's got 5 7-segment displays, right?
Okay.
And then it's
Yep.
got 74HC161 shift register drivers. Okay, fine. Shift in the data, and Bob's your uncle, right? And they're cascaded together. I wouldn't have done it that way. But anyway, they're all cascaded together. And then there's no lead dropper resistors, right? So I thought,
Okay.
what's going on here, right? There's that, normally if you're designing a 7-segment display properly, you have individual lead dropper resistors on each segment. So so you can calculate exactly how much current is going to flow through each segment, right?
So I'd say you could probably broaden that out to when you're designing anything with LEDs and you're driving with voltage, you probably have a resistor somewhere in
you
line.
have a resistor dropper. You're supposed to have a resistor dropper,
yeah.
right? That is correct design process, kiddies.
Yeah. Sure.
Right.
Sure.
So anyway, this doesn't have any lead droppers, right? So I was reverse engineering the circuit, and they had this big 47 ohm resistor on there, and I like a big through hole jobby, and I thought, they're using that as one big dropper resistor for the whole lot, and of course that's bad practice, right?
Sure.
Because then you're going to get different brightness on your display depending on how many segments you turn on, right? Basically, if you turn on all the segments, then you're going to get like the current, the maximum amount of current has to be shared, so it's going to dim. So all your segments are going to be dim. Whereas if you have just one segment turned on, or just one single digit or something, then it's going to be super bright, right? Because it's only got a 47 ohm dropper in there, right? Yeah. So anyway, but I was wrong about that. It doesn't even have a freaking dropper resistor. And so they're relying on the RDS on of the output MOSFET, the high side output MOSFETs of the 74HC164, right? Which I did in the video. I actually, through the data sheet, you can actually calculate that with the VOH drop, right? So based on how much the VOH, it tells you that in the data sheet. How much does the VO high voltage drop based on X amount of output current, and then you can calculate roughly what the output impedance in quote marks is, right? The output resistance is, and so they're using that. I think it was 40 ohms or something. I don't know, but and
so basically, it's just that they're not driving when they drive it high. They're not driving it hard enough to really get a low resistance, and they're just relying on that. Is that it?
Well, no, the 74161 is trying to drive it as hard as it can, right? Because it's a digital output, it's either 1 or a 0, right? But the inherent nature of the 74HC logic drive means that they're only wimpy output transistors, right? These aren't designed for high current.
Yeah, that's what I meant.
The maximum output current is like 20 milliamps per pin, right? And here's a trap for young players, right? Go look at any 7.4 series digital logic, anything, right? Or 4000 series CMOS or whatever. And they'll say, okay, you can do 20 milliamps per pin, per IO pin. So you can go, oh, great, I can drive my LEDs at 20 milliamps per pin. No, you can't. You can't drive your 8 output LEDs, right, at 20 milliamps each, because if you look at the maximum specification for the chip, the power pins can only support 50 milliamps maximum. So, so you've only got 50 milliamps total for the whole chip. So you can't drive each individual IO at 20. So, yeah.
But actually that benefits in this scenario too, right? As long as you're
then you're kind of, Anyway, so they're using
overall
that.
8.
Yep.
Yeah.
So anyway, the common cathode connection on the LED displays, all of them, 5 of them in parallel, right, all goes to one pin on the connector, which then on the other board I checked out actually goes into an NPN transistor down to ground. So they're using that as blanking. Right. So using that, you can actually blank the entire display, but still there is no current limiting. So you could like bias the transistor like partly on, right? Yeah. So it kind of like you can control it that way, but you still got the brightness problem. And then, it's bad design. And I'm just surprised to see it in here. And there was just no reason to do this, right? There was room on the board to put individual dropper resistors. There was no need to do this, right? So, yeah.
Just a quick clarification. You said the 74HC161, is that right?
No, the 164.
164. Okay.
That's 164. Yep. 74HC164 serial shift register. Standard jelly bean stuff.
161 is a counter, binary counter.
Yes. 161's a asynchronous counter.
Yeah.
Isn't it?
Yeah.
Or am I wrong? Is it synchronous?
Oh, I don't know.
Hang on. Asynchronous. No, hang on. No, synchronous. Yes, synchronous. Yep.
I'm really only, I use shift register sometimes. I use 595s. Yep. But like.
Yeah, 595s is a nice go-to
one. Not using much. I guess there's, what's the 00? Is it NANDs or what is
NANDs? Yep.
Yeah. And so like once in a while man.
Right.
Not much 7.4 series logic. No, I just never had it. I was never really, I was just on the trailing edge of that,
Yeah, right. So. No, see, for me, I like memorized all these as a kid, right?
Because exactly. You knew data books.
You had the data books. You had the 1,000-page TIT. I've still got it, right? The 1,000-page TITTL data book, right? So you'd memorize all of these chips. And I can remember going for a job interview once. I don't know if I've ever told this story, but I was going for a job interview at a company that they had this idea for like video at the time. This was pretty novel, right? Video intercoms, like sort of not really because the internet wasn't around then, but video like for
like
hotels,
wired
wired video.
Yeah. So like coax cables
each door, something like that. Anyway, so they had these video things, and the guy thought he was going to be to quote, I'm going to be richer than Bill Gates. And I went, yeah, okay. Anyway, so I was offered the job based on my knowledge of 7.4HC logic. All of his questions were, can you explain what a 7.4HC 244 does, and et cetera? And he rattled off all these numbers, and he was stunned that I knew what they were, right? Huh. And he went...
So after a certain time, it was just like I got to try and test this guy.
But he was absolutely stunned that I actually had chip level knowledge, and I knew what these numbers were off the top of my head.
Was he calling them out by memory as well? So like, did he have the same knowledge in his?
Memory? Oh yeah. So he was that was I don't know if he had the same in depth.
He was the hardware guy. Oh, got it. So
yep. Well, he was like the company founder, and he was a hardware guy. Yeah, like it was only a small like family company. It was only like 3 or 4 people working there or something.
Wait, you mean he didn't get richer than Bill Gates?
No, he didn't get richer than Bill Gates. It didn't pan out. So I actually followed them a few years, and it was anyway. So I was offered a job based on the knowledge of my 7.4 logic. It was hilarious. He was stunned. I guess nobody had actually, passed his questions before. They go, I have to look it up,
so.
And
Yep,
no, I
yep.
just rattled it off and gave the pros and cons of those chips.
Which,
And I
to be
said, oh,
fair, is a legit answer. Just come on.
oh yeah, no,
You don't need
totally,
to
right?
know.
Yeah.
Yeah.
Yep. So yeah, but he was just so used to getting that answer, I guess, that he was just, I can't remember exactly what he said. I think I discussed it with because I knew like I could see the shock in his face and like wow, like stunned. And then he did more numbers and I rattled them off as well. And he was just I think we might have talked about, I don't know, it was so long ago. Can't actually remember. But anyway, there you go. Geez, that was a tangent.
Humble brag tangent.
Anyway,
humble brag. Just a brag.
For those playing along at home, I didn't take the job. It was like it because the vibe of and also also he mentioned at the end of the interview, do you mind if you work in an environment where we were talking about religion all the time?
Oh my.
And I kind of said, and that, the alarm bells start going off. So I think they are a fundamentalist,
Wow.
Yeah. So he actually said that.
I mean, at least he asked up
No,
front.
yeah,
That's
no,
nice.
he told me that that's what they'd be talking about all day they'd be talking about religion. I might have taken it maybe, cause technically it sounded really interesting, but I didn't take, it was on the, and he offered for me to move in with his brother or something, because I'm going, it's far. It's on the, I actually turned down the job and my excuse was, no, it's too far. It was on the other side of Sydney and it was there'd be too much travel and everything. And then he offered,
this is getting weird, Dave.
You can, my brother, you can move in with him and he's just down the road, and it was
my. Okay.
and I'm going, nah. Yeah, nah.
Okay.
So, yep.
All right.
Yep. There were too many alarm bells there.
Too many question marks.
Anyway, where was I?
Oh my gosh.
I was talking about overloading these damn things. So it was so this has actually a triple, this has a double whammy problem at least. It could be a triple Lindy. I don't know. For those who've watched Rodney Dangerfield, no. Triple Lindy, no. This is way over your no.
I mean, I know some of his stand-up stuff, but
movie recognition, Back to School. I believe it's called Back to School, and he does the triple Lindy.
I've seen Back to School. That's because he's a diver. That's right.
He's a diver. The triple Lindy.
The worst.
You have seen it.
God.
You have seen it. The triple Lindy.
Yeah.
Yes.
Because he decides to go back to school with his son, and he's the street smart real estate developer.
Yeah.
He's basically the exact same character as he is in Caddyshack, and I'm there for it.
It's great. It's just hilarious. I love
He's a little more humble in Back to School.
Yeah, surprising. Yeah, it's great. Anyway, the triple Lindy. So so we have the problem of not having individual droppers and relying on the RDS-on of the transistors, right? Which is problem number one. And then problem number two is that because the 74HC164 is not designed to be cascaded, right? It doesn't have a cascade output to go onto the next chip. So you have to tap off the Q8 output, right? So you've got to tap off the last digital output. But because you're using that last digital output to drive hard the LED display, then its output voltage is going to drop so low that it could actually not then have a high enough logic level to drive the next chip. So what you've got to do, what you probably have to do, if you drove them at a low enough current level, you could probably get away with it, maybe, but it might change based on how many segments you've got turned on. That's the that's the crazy thing. That's the mind-blowing thing. And what's mind-blowingly bad about this actual design, this is what I'm going to mention in the video, is that they have to use that output, which is driving the LED hard, to then send the data into the next chip, right? So what you have to do is blank the display when you're shifting the data. Well, you would do that anyway because you wouldn't want to see them because they're a non-latch shift register. So you wouldn't want to see, if you didn't blank the display while you're shifting the data in, you would actually see the data shift across the display and it'd flicker and, do all sorts of weird. Right. Yeah. So you'd have to do that really quick if you didn't want to see the flicker, but technically you'd see it. So you have to blank it, not only so you don't see it, but also so that you don't screw up the bloody logic levels when you're shifting. This is oh my God, how bad can this design
So
Hey.
it's safe to say you're not going to follow the same analog pattern on this one.
Well, I kind of have to because I'm reusing the board. I'm interfacing with this board. That's why I'm talking about it because my circuit that drives this has to take all this into account.
Oh wait, so the 74HC164s are built onto the
They're
display
built
board?
onto the board. They're built onto the board, which I'm
Oh, so
reusing, right?
you basically only have like a serial line into it,
I
or
just have a serial
shift
line
line.
in, and I have access
Yeah,
to the
the latch.
common, the
Yeah,
common collector pin and stuff like that. But that's it, right?
got it.
Yeah,
Oh
yeah.
yeah,
So
that's
my
weird.
circuitry, so any design I do has to take this into account, right?
Hmm.
So that's why this is such an interesting thing, right? If I was redesigning from scratch, I wouldn't do this.
Yeah, that's what I mean. Is like it would even make sense to like try and replicate the size of the like even making your own LED segments and stuff like that.
I could, but the challenge is to reuse the existing board. I could simply
Ah,
redesign the
okay,
board
okay.
and put in my own displays and but that's kind of like, that's kind of like a cop
Yeah, yeah,
out.
yeah.
I kind of like reusing the existing thing. It's got the foam cut out in there. It's all but I could reuse it. I could
Yeah,
redesign
I
the
mean, I
board.
meant like form fit function type of replacement, so like something that looks as close as possible.
That looks as close as possible, but where's the challenge in that? Like, I don't know. I kind of like the idea of reusing.
I mean, there is some challenge, but it's mostly like sourcing and like, matching behavior and stuff like that. And usually when I've found in my past when I had to go and replace something like that, the real thing is usually then user perception. So then it's like, oh, well, I ordered this bomb ass looking thing last week. And then the one that came this week, because apparently I'm ordering multiples, it looks different. What happened? And then
Right.
your boss comes to you and he says, you need to make the brand new shiny thing that you spend all the time sourcing. You need to dumb it down and make it look worse, so it looks like the old thing.
Got it. Been
I
there.
don't blame the
Done that.
boss,
Yep.
but yeah, it's
Yep.
just something that happens. It's
Right.
part of your life now. So there is
Right.
challenges. You're right. I think it's a different type of challenge and probably not as tough.
So you're going to recommend that I use a microcontroller and I redesign the whole board.
What if you just threw the whole thing out and started from scratch and build your own bomb-looking thing?
Right. Oh, yeah. Why even reuse the case?
Yeah,
Like,
why even? Yeah,
yeah.
exactly.
No,
Yeah. Couldn't you 3D model your own thing
yeah.
that looks
3D
like a
print it and,
crazy ass
yeah,
like
yeah. Right.
mine?
Oh,
Yeah.
God. I
No,
don't know.
I mean I get what you're saying. Yeah, it makes
Yeah.
sense. It makes sense.
Yeah. Anyway, that was, and that's why it was a 50-minute long video because I'm kind of like reverse engineering this thing
But
going,
it's
huh?
not
What's
the
what's going on here?
only reason why, Dave.
What? What's the other reason? Is because I like to talk
Your name
about
is Dave
circuit design?
Jones. Yeah.
Yeah, well,
Yeah.
yeah.
Uh,
Anyway,
you know, a
mm,
side of waffle.
right.
With most orders.
Yeah, but I go through the video, right? I do a 2-pass edit.
Oh,
I
yeah,
go
yeah,
through it a
yeah, yeah,
second
yeah.
time and
Two
I
pass
go,
at it. Yeah, I get
can
it.
I take
Yeah,
out
yeah,
this
yeah.
information? And I go, nah,
Yeah, two
somebody
pass at
might
it.
find it useful.
Ah, it's
You
your
know?
two pass at it. Yeah, yeah,
Like
yeah,
it's,
yeah, yeah. Editing. Yeah. Yeah.
boy, I just can't do it. I just can't
Yeah.
throw out potentially useful information to someone.
Yeah. Yeah.
That's my problem. Anyway. Yeah. Anyway, so I'm going to go after this. I'm going to go actually reshoot that with a simpler version. So the main channel, you just see here's the reverse engineered circuit, and here's what I found,
Yeah.
rather than the
Cool.
whole process of doing it. So if you want to see the whole process, it'll be on the second channel's 50-minute video. Not knock yourself out,
Yep.
So
Cool.
yeah, because I don't think it, because there's two types of people who want to watch this video, right? I think there's the one who want to see the reverse engineering process, right? So those are the ones who want to watch the whole 50-minute version, right? And
Yeah. Uh-huh.
and then there's others who just want to, no, I just want to go along on the journey of this project. Please just give me the summary of what you found, and then we'll make a decision where to go on part 2 and part 3, etc. Which direction to take it. So there's I've got to cater for two audiences here, I think. So that's why I've decided to split the video. Yep.
Makes sense.
Yeah. Yep. All right. Enough of that.
What else do you want to talk about? We have many other news items on the list. Probably most interesting to you personally is that Google begins publicly testing its AR glasses.
I've not seen any info on these. What do they look like? What application do they have? Like,
I think the
what's
main thing
where
is,
they're at?
Dave, Google Glass is back, and I'm vindicated.
Right. Okay. So it's an upgrade to Google Glass essentially.
No, it's a new thing. It's a new thing, but
Right. Okay.
I really just want to make a Google Glass joke, and that's all I have to say
Oh,
about
okay.
this.
Yep. Because
I
you
don't
are
think
the
this is
proud
actually
owner
anything.
of
I still am.
Google
Yeah,
Glass.
I'm staring at the case right now. Actually, yeah.
Oh, all right.
I
Okay.
turned I turned them on a couple days ago, and
Oh,
they
okay.
still
Yeah.
have
Right.
photos from the last time I turned them on and took a photo. So I'll probably do that about every 3 years. It'll be like
Right.
a time
Yeah,
capsule
got it.
on my face.
So why did you stop using it? There was just no
Oh,
killer
software
app.
support.
It was what?
Yeah, software support fell off.
Right. Okay. Right.
I did open it up. When I opened it up and tried it out, I forgot how it worked. I forgot what was on there, or whatever. I did open it up, and I was like, "What's on this thing? What's on this thing?" And like, it doesn't have a connection to there's no app anymore. I have a new phone. It doesn't connect to the old phone, whatever. And there's no way for it to get to the internet. So now it's like a standalone thing. So now it's a device that sits in your face, and I went to the standalone, mind you, standalone app for translation, and I turned on the overlay, and I said, "Show me Portuguese." And so I looked at something in English,
Yep.
and on my face, it did the overlay in Portuguese. And I was like, "That's not bad." This is technology from 2014. That's 8 years ago, and
That
it's
is a
doing this
killer
without a
app.
connection to the internet.
That is
Yeah,
definitely a
that
killer
is.
app. Like if you were like you wouldn't use it every day, but if you're going
No,
overseas
of
or
course not.
something,
Yeah,
that's a
right, right,
killer
right.
app. Yeah.
Yeah, that's
Yeah.
so.
Right.
Nobody needs it really, but yeah, it's a.
So I assume this new one, like I can't even get like they don't even have a real photo of it in this article here. Like
No,
what does it
this is all
this is just a
PR
stock
fluff.
image.
Yeah.
It's just a like
I think what it is like, sci-fi never doesn't have, like a display in your face. I'm reading a
right.
book right now called a Rondo, and it's just like all about that sort of thing in the early chapters. And like, it's always there it's always there. It's just always there. And sci-fi can't get away from this concept. And I don't think any big tech company will never stop. I don't think Google will ever stop trying this, and Apple's working on it, I'm sure. And, Snap has it and whatever. And it's a really hard problem to solve, not least of all because it's a screen that's, 5 centimeters away from your eyeball. Like, it's not like
Right.
it's not an easy focal distance either.
No,
And so like there's a
no, it's not.
lot of hard
Yeah,
problems to solve.
Yep.
So yeah, maybe someday, who knows? But it is also a great way to walk into oncoming traffic by accident when you're reading your text messages. So
But that's right. Okay, because you're focusing near field and your
exactly.
brain's focusing as well, rather
yeah,
than
your brain is just it's just a distraction machine,
Yeah, yeah.
like a phone is, but
Right.
it's just close to your eyeball.
Yep.
So
Yeah.
I really have nothing else to say about this
See,
other than I wanted to make a joke about it.
Will that
Google
create
Glass.
a greater problem? Right? Because we already have the huge problem of people on their phones, right? I mean,
Sure.
they've even gone to the point of haven't some cities installed traffic lights on the ground because people are just constantly looking
Oh, I haven't
down.
seen that.
Yeah, I'm sure if you
Wow.
Google that, it's somewhere, right? I'm sure if you Google it, on your Google. Yeah. Anyway, here are we.
Dutch town now installs traffic lights on the ground for texting
Yeah, yeah.
pedestrians.
Yeah.
Huh.
I
Okay.
don't think it's a joke. I think it's
No,
I think it's
good.
totally I think it's totally legit, right? Everyone's just looking down, right?
I mean, this isn't disingenuous though, because everybody knows Dutch people don't walk; they all ride bikes. And it's
Right.
awesome.
Okay. Yeah. Got it. Boy.
That's kind of cool, though.
Yeah.
I'm
So
okay with that.
it's just not. So is this going to create a
Worse.
greater
Oh yeah,
a greater distraction because it's in your face? Like at least the phone, you've got to take it out of your pocket. You've got to switch it on, do the swipey bloody thing or whatever you do to unlock your stupid shoe phone, and then you've got to scroll to the app, and then you've got right.
Shoe phone.
But if it's just pumped. If it's just pumped right in your eyeballs all the time as you're walking around,
Yeah.
like sure you can have them up on your head, right? You can actually move them up and it's out, but it's like it is vastly easier, right?
It's getting worked up.
It's
Dave's getting
vastly
worked up,
easier
folks.
to flip the glasses down. I'm doing it right now. I actually have my glasses up on my forehead, and I flip them down. It takes less than a second, right? Whereas to get my phone and open it up takes bloody 2 hours or something to start the damn thing up. So is this going to lead to a greater distraction of people just constantly distracted all the time? I can picture people in the freaking gym class. It already pisses me off when I go to a gym class and every single person is just sitting there looking at the shoe phone. I'm the only one who turns up without a bloody phone, right? It's already
We've heard a
doing that.
couple times here, Dave.
I
We've
know.
already heard. We've heard this.
Imagine if they
We've heard
have
it
the
a couple times.
glasses. They'd be wearing the freaking glasses
I
in
mean,
the
this is
gym
actually.
class.
You know, like I'm on a lot of Zoom calls and other things, and like, you know, when someone's like staring off into space because they're like on a different screen writing text, like it's going to be that. It'll be that. So
Right.
yeah, I'm not saying it's a positive thing. I'm trying to get back to the point. I was just trying to make a joke about Google Glass. We can move on. Let's find another story to move to. What else would you like to talk about, David?
Oh, we can talk about DigiKey because we were talking about that before the show. I really
We
like that.
were. Yeah.
We
Yeah, that
haven't.
was pretty great.
You've watched it, but I haven't watched it all. I've just
I
scrolled
watched some of it.
through some of it. Yeah. It's
Yeah,
a
it
uh,
is. Go ahead. Yeah.
it's an RV SWAT channel, and they're nomads or whatever, right? That travel around the country in an RV.
Yeah, so they call this work camping, which is all one word
Work
apparently,
camping.
but it's like camping and work.
Yeah, work camping and working. So yeah, so they just go from town to town and they find a job for a month and they stay there for a month and then they move to the next town, I guess. And they turned
That's
up
right.
in Fever Falls and they went to work at DigiKey. And this is the video of them, both of them, is it? Yeah, both of them working at working at DigiKey, and it's good insight into the DigiKey factory.
I think that's why my friend sent it to me, because it's like you get a really cool look at, like, you know, what it's like just picking parts and, you know, standing on the line and figuring out how to put everything together. And, you know, some people are there permanently, some people are, you know, temporary labor like this, and it's
and
cool
it isn't as automated as you think. Like it's, you know,
that's right. Yeah,
like it's mostly manual. You know, he's walking up and down. There's little cardboard trays on the shelves, like in some old, you know, a surplus warehouse or whatever. You know, these old cardboard trays.
The
and
parts room at my old jobs. Yeah,
yeah, right.
I mean, like, it looks pretty similar. Yeah.
What was the one that closed down recently? And Jerry Ellsworth scored a whole bunch of stuff from there. What was the one in California somewhere that closed down? The surplus place?
It was one of the last ones.
Yeah,
it
was like practically the last
I don't remember
one.
the name. I didn't know by name because I think Jeff Kaiser also posted about it.
Yep. All right. And and it's just got these
like,
old
they're down
rusty
to
steel
very,
shells.
very few.
Yeah,
there's very few in the
left.
Bay Area specifically.
But this is what it looks like. I'm staring at it right now inside DigiKey. It's very similar. It's got like these steel shells with these little cardboard trays with a barcode on the front, like, and you just pull them out, and it looks messy as. Right. And it's just, and they just walk down this narrow aisle, and they find the one that they want, and they pull it out, and they get the parts, and they push it back in. And, you know, really is something.
Yeah.
So,
I can't imagine. Do you ever have to do like inventory counts?
Yes. Yep.
Yeah. So like, if people don't know, like, what you're doing basically is, like, you think about all of these dusty trays like Dave's talking about, right?
Yeah.
The system thinks that there are 455 individual 74HC 146s or what it is,
164s. Yes. Nice score back there.
Yeah, and they think that there's that many. There's 455 of those in that tray, and they're working down. You know, like the people are pulling. They pull 10, they pull 150, they pull, you know, whatever it is, and they think they get to the end, and it turns out actually they only had 300 in the bin, and that's why you get the notices. Is oops, we actually don't have this part. Sorry about that.
Yep.
But the bad thing is that, you know, every once in a while you have to go back through and actually count everything that's in each and every container, and then update the numbers because of wastage, spillage, whatever happened, you know, something that fell behind.
Oh, just imagine what would be on the floor under those shelves. Just imagine how many parts.
Gold, Jerry, gold.
Just sweep them up, and you can sell them by the bag. Oh god.
Digi droppings. That's what they would call it.
Digi drop-ins. They're officially called Digi drop-ins. Yes. Oh, this is great. I so want to visit the DigiKey warehouse. It's on my bucket list, you know. That's kind of a sad bucket list, is it not? But, you know. Oh, boy. Yep.
Well, you're a simple man with simple taste, Dave, and that's all it takes. You know?
Yep.
Yeah, so it's cool to see kind of. I was surprised actually by I get the bags, I get the labels, right?
Mm-hmm.
It's just a label printer. Like, I don't know what I thought it was going to be. It's like, but that's also how they figure out what's kind of up next and stuff like that. And I don't know. Fantastic. It all makes a lot of sense when you look at it, but it's like, oh yeah, okay, all right, cool, yeah.
And they're not wearing wireless anti-static wrist straps.
Yeah. I just said so.
Unlike LCSC.
Yeah, right.
You don't remember that, do you?
I don't know.
I actually busted them. They actually put out some promo shots of their warehouse, and people were using those those wireless anti-static
Oh, the
wristbands.
wireless ones.
Yep.
Oh, got it. Yeah.
So I sent them an email going, "Hey," I linked them to my debunking video of the wireless anti-static wrist strap, and they
Got
went, "Oh, that's embarrassing. Sorry, we'll fix that." And they actually announced that that they're that they're fixing that. So if you get your parts from LCSC, you're welcome.
I do. Yeah.
Right.
Get them wherever I
Anyway,
can these
yeah.
days.
Oh boy. Good stuff. Yep. And you might have seen that the JCar warehouse. I did the JCar warehouse video there.
I did see that. Yeah.
They're relocating. They're actually their new warehouse, which I have an invite to, actually has robot pick and place. So I'm curious to
Ooh.
see what that's like.
Yeah.
And the good news is, for those playing along at home, they have not laid off any full time staff. So all the full time staff will still be
So
there.
just for growth.
Yeah, So the new warehouse is robot pick and place, and
It's
they
usually
had
how automation goes. It's usually not because like you're just like wiping out the workers. It's because you're augmenting them or
or
you're growing
augmenting
so
them or
much and you
something
just
like
can't.
that.
I mean, like it's still really tough. I don't know about in Australia, but it's still really tough to hire people. And then
Yeah.
you
No,
know,
same here. Yeah.
yeah.
Yep. And the so I don't know. Like I'm kind of picturing. Don't know if I'm going to be wrong, but I'm picturing those robots that like crawl up the sides of the racking and move across. X Y,
Oh,
and then
yeah.
pick and get the box and then move it back out. I'm kind of picturing one of those, but I don't know what their robot. All they said is it's a new robotic pick
Yeah.
and place warehouse, and some goods were too big to go into this new warehouse, and that's why they're actually clearing those out. And they have another
Oh,
warehouse
interesting.
just for the big bulky stuff, which you can't do the pick and place on. So yeah,
Yeah. I mean, I've seen the Amazon. Who did they buy? They bought. God, that was so many years ago now. But basically, that's like where they bring the entire shelf over to an actual
yes,
picker,
the
right?
entire shelf moves, right? The robot goes
Yeah.
up, picks up the entire shelf, and moves the shelf to you. So I
That's
don't
right.
know
And so what
what the
you're
new.
basically
Yep.
doing is you're just cutting down on that walking up the aisle like
You're
you'd see in the
cutting down
DigiKey
on the
video.
time, yes, required to
Yeah,
walk. So you're not
right.
actually,
And some more flexibility of storage and stuff like that. But you cut
yep,
down on is like if you look at the DigiKey warehouse, those shelves are humongously tall because then you get extra storage for like long-term storage.
right.
It's out of reach of any person, but you still get long-term storage up there. So you lose that with a
Mm,
kind of a more mobile, like robot moving the shelves kind of thing.
yep.
Then I think about like there's like the
Well, yeah, because there's two ways to do it. You can bring the shelf to you, or you can bring the individual box to you. Or an advanced thing would be bringing
yeah
an individual part, but then you got to have like it'd be like one of those. We've talked about that food distribution warehouse that has those
yes
XY
right
robots on the
with the
roof or whatever,
holes.
and then
Oh,
then it can drop individual food items into the a box, and then the box comes to you and it's already sorted with all the parts. I don't think it's going to be that. I'm not
I
really
don't think
expecting that
that's a
level.
really complex thing.
Yep.
I don't know. It depends how much they're investing too. Like I've also seen there's a assistant robot that basically like again in it's almost more like the DigiKey case where it's going up the aisle and it's got an arm on it, but it's able to move up and down aisles and then it picks directly off a
Right.
shelf
Yep.
and depending on how the shelves are aligned and stuff like that. But it's tough. It's a
Yeah,
tough
but
problem
then,
for
like,
sure.
every product's a different shape and size and weight and everything.
Sure.
So,
Yep.
it's
Yep.
like it's very difficult. So unless you have everything in like
Like
preset
standardized
bins, like
boxes.
standardized
Yeah.
boxes or bins, it makes
Yeah.
the
Yeah.
robot pick and place concept very difficult. So,
Yep.
yeah.
Yep.
Anyway, I have been invited for a tour of that, so we might see something interesting there. So, stay tuned for that.
Cool.
Yeah. Of course, I've tried to get into the Amazon one, but you cannot get into Amazon.
Yeah, of
That's
course
just
not.
no, they're
You
incredibly
have to go and
involved.
work there.
Yeah, you have to go work there, or you
Pee
have
in
to
bottles.
be, one of the major news networks, and then they've got to vet all
Yeah,
the
even then.
footage, and then
Yeah,
like,
totally.
yeah, no, I've been told specifically that no, you will not get your camera in there. It'll be over their dead body that you'll get a camera in the Amazon warehouse. So yeah,
Yeah.
not going to happen, I'm afraid. We'll have to settle for JCar. Yep,
Yeah.
cool bananas.
So where I would like to get a tour
Yeah.
is Skywater, which just announced with Google they're moving down to 90 nanometers. So that's the ones that talked about Matt Venn doing the zero to ASIC course, and this
Yep,
is
yeah.
Tim Ansel's been on the show a bunch before.
This is the open source ASIC
That's
stuff.
right.
Yep. Yep.
Mohammed from eFabless has been on the show. So basically, all the people working with the kind of the open PDK,
Mm-hmm.
and so Skywater had an open PDK, and Tim's been working on from the Google side to do this sort of thing. They're now moving from 180 down to 90, which is pretty exciting.
Yep.
I wanted to tell Dave this because we were talking a little bit about like Thief River Falls is in the middle of kind of nowhere, but
No way. Yeah.
it is in Minnesota. And Dave's like, well, what else is in Minnesota? And the answer is Skywater. Actually, Skywater Technology is there too. It's
there
in
you go.
Minneapolis,
Right.
which is like the metropolis of
You're right.
the
Of course.
state. But
yeah,
it is there. So it's actually, I found out it used to be, it's right next to the Minneapolis St. Paul airport. That makes sense because then you get all of the logistics.
Yeah, but the fab isn't there, is it? Is the actual fab there?
It is.
Oh, okay,
Yeah, it is.
right.
Yeah, it's
Oh, cool.
right on the
Cool.
lake next to
Right.
it.
Oh, nice. Well, it has to be on the lake because fabs need water. They need lots of water. So I assume that's why it's near
Sure,
the
they
lake.
do, but I used to work at a fab in the middle of Austin, and there's not a lot of
Yeah,
water
right.
there. So.
Okay. Yeah.
And
True.
also, Microchip has fabs, and
Yeah.
Intel
Yeah.
has
Yes.
fabs in Arizona.
Yes.
So
Yes, they do.
I also thought that for a long time, and then I'm like, wait a second.
Well, we were just reporting a couple of years ago that Taiwan had to reduce its chip output because of a water shortage. So
Sure, but that's probably a lot more chips than these guys. So.
right.
But this used to be. So I found out recently that this used to be a Cypress facility. I didn't realize
Oh,
that.
okay.
So
Right. There you go.
yeah, so that's what. So Cypress used to have in-house.
Right.
Now Infineon, and now they that expanded with private equity. They bought it, and
Cool bananas.
now it's Skywater.
Things are
Yeah,
happening in the chip business, and well, it can't come too soon because we know what's happening at the moment. So
yeah.
Yep.
Yeah, and so in the U.S., probably people don't care too much, especially maybe Australian people that I'm talking to right now. But that stuff did pass. The money is in the pipeline. So all those announcements we've been talking about for months and months and months, and there's actually new ones even. So there will be apparently new chip fabs in about 2 to 3 years, probably more. They'll probably be up and running, and it'll be interesting to see. So we might have a glut of chips in 2 to 3 years, which would be really interesting. So we're in a very big dip right now in a sourcing perspective, but
got it.
What does that mean 2 to 3 years from now? Who knows? Aside from the global impacts of what does or doesn't happen, assuming steady state on all other fronts, like Taiwan still outputting what it does now. Now, if like TI and Intel and all these people that said they're opening more and more,
Yeah.
if they're all
It's
there's
getting
more of
very
these
interesting.
fabs now.
Yeah.
Does that mean there's more parts available? Because like that could mean cheaper parts. And it's like, oh, okay, all right, I'm down for this. Assuming everything goes okay.
Intel ain't making your little
No.
voltage regulator. So.
They're not. Yeah. But it's still just interesting. That could drive.
Right.
So then you think about the 5-year mark, right? So then 5 years from, again, this is all assuming everything else doesn't go to crap, which who knows. But if everything else was stable enough, so then 5 years from now, there's all of these other chips. Like, what does that enable? It's just, I don't know. It is an interesting time in the chip industry.
Got it.
Not least of all, because just today I saw one of the big chip companies that I follow, which is Nordic Semiconductor. They have a job opening for a RISC-V designer.
Oh, there you
go. Oh, okie dokie. So, I know they're not the only ones. They're not the only major chip companies looking at it. And they're fabless as well. And they're not the only ones looking at it. But I think we're going to see more stuff like this over time. A lot of the expressive stuff is already RISC-V.
Yeah.
I'm sure Nordic's doing that too. And it's just like, all right, so what does that mean then too? I don't have any kind of crystal ball on this stuff. It's just it's an interesting time that we're living in here.
Well, nobody really predicted the RISC-V thing. Nobody predicted the
I bet the people in Berkeley that
growth.
invented it.
Oh, well, yeah, but you can say that with hindsight, right? But it could have completely flopped, right?
Yeah, you're right. Yeah, I was talking about the researchers who were inventing it, but yeah, they were probably not oh, this will be a huge deal, right?
In 2 to 3 years, every major manufacturer will be having a RISC-V division. No, right? It seems to have just I don't know. There's something about people want to jump onto the standardization bandwagon. Maybe
open source. I guess.
Well, what helps that there's no
12 years ago. That's when it was first introduced.
But so it's not an overnight success, right? I guess.
Sure.
But still, it did. As far as we're concerned, it seems to have exploded pretty quickly. Like, it seems to, once.
I remember we got in trouble for not understanding it about 5 years ago. I think that was the
Right.
first time that we started
Okay.
talking about it on the
Yeah.
show and being confused about it. Maybe more than that. I
Yeah.
bet I can go back and look. But yeah, it's definitely like it's a lot of places now. And
Got it.
Dave's perception of this might be just because I talk about it a lot too. So like that could also be the
Yeah.
but I whisper in the ears of many powerful people.
Bragging.
Chips are hard to get right now.
Anyway, we're over time, so we've got the dregs. What are the
Oh yeah.
dregs? Breaking news, straight off the teletype. The Facebooky Metaverse, Mark
This made
Zuckerberg
me laugh.
lost $2.8 billion, not in a year, but in a quarter. $2.8 billion loss on their Metaverse division.
Suck it, Zuck. Suck it. I mean, it's a drop in the bucket for him, but
We
still.
said it. We called it the other week when we said it's either the Oasis or bust.
That's right. Yeah.
It's either the Oasis or bust. It's like there's no in between here. Like there's no. I think you have to go the full Monty, or
Ah,
it's just gonna the wheel's
everything.
gonna
I
fall off the
actually
billy cart.
I saw this article and I was like, it can't be that bad. And I went and watched a video. Oh
Yeah.
my god, it's so bad. It's
I've never
really
watched a
just like,
video of the meta. Well, I
oh, you
maybe
should. It's so
incidentally think.
corny.
Yeah, I know.
It's so
Well, I've seen
corny.
like little snippets of it here and there, and it just looks stupid. It just looks so
So
dumb.
dumb. It's like
Yeah,
everything's just like avatars of like,
yeah,
like
yeah. No,
tigers that
it's
are like human form and
yeah,
like dancing.
it's
It's like, what?
no,
Like
no,
this is never gonna catch on. This
no,
is like,
no. This is dumb.
like someone buying their grandchild like a toy and thinking it's the hot new thing. It's like, no, no.
Nope. It's no. They'll just use it and go, and then
Yeah.
yep. No, no,
Yeah.
loser. $2.8 billion loss in one quarter. Sucked in.
Oh
And
my god.
and what's this about? Telit and Tally's announced the creation of leading Western Internet of Things grown solutions provider.
Yeah, it's
I didn't know Tally's, who's my former employer, technically.
yeah, they have an IoT division, and so basically they got absorbed by
Who
Telit.
knew and who's
Telit's
Telit?
just
I
kind
got
of
no idea. I got no idea who.
Telit's like a cellular module, but kind of
Right.
like broader than just the chipset.
Yep.
So they kind of make the modules, but then some of the software and services around it, that sort of thing.
Got it.
I think the bigger one is actually Semtech buying. They actually they did announce they're going to be buying Sierra Wireless because Semtech are the ones who make LoRa chips,
Right.
which
Yeah.
goes into every LoRaWAN thing. Remember, LoRa
Yep.
is the physical layer and LoRaWAN is the network layer. And they bought a cellular company, which like a cellular module maker, which is
Right.
like, personally, that's a bad look. Yeah, I mean, like it's like, oh, maybe we can't make that much money on LoRa. It's like, oh,
Right.
really? Like, okay, well, wait, should we be using this? And like there was Stacy from the IoT podcast, Stacy on IoT. She wrote about this thing about helium. So helium, there was
Oh yes,
someone.
yeah, the
Did
helium
you see
thing.
that thing on Twitter? So like helium's been a bunch of places. They've pitched us before. They've pitched NPR. There was an NPR story recently about being built a miner being into a house. And like I will agree that while I hate most cryptocurrency things, Dave likes it a little bit more. While I
Yep.
hate most cryptocurrency things, it is probably the closest use case for a cryptocurrency, which is like basically tracking that packets have been received. But my argument is exactly the argument that the analyst was making. Like, look, there's nobody using the other side of it, and they're like,
Yeah,
well, we have to
exactly.
build the market for it. It's like, okay, but like, here's my only proof point. I have never seen a single thing, and I would love to see if anyone has heard this otherwise. I have never heard of a single marketing campaign that says, are you building a LoRa device? You should use the Helium network as your backhaul, right?
Yeah,
Like
right.
you would think that if they're spending all this money on, cryptocurrency and all these other things, why aren't the hardware engineers, and I know a lot of them, and like I'm
Yep.
into the IoT space, whatever. I've never seen a single thing that says, here is what you
Yep.
should do to go and use the actual, proof of coverage, whatever. All of these people that are buying, all of these suckers that are buying these miners, no offense, and like there's nobody using it, and it's like, so what are you going to do? You're just going to go design it just for the huge customers? Why wouldn't you try and sell it to like the little folks? I don't get it.
No, there's other, and there's other associated ones like that, like Power, for example,
Yeah.
which is an Australian company, and it's a crypto based thing, but it's designed for power sharing. So if you've got solar power in your house, you can share it with other houses in the street, and then it bills everyone like, you can trade energy kind of thing.
Sure.
And
credits. Totally.
Yeah, and they've got big deals with some major energy companies, and they're actually trialing these in actual locations. People are actually trading energy, right? And so it's all there. It's not just so they're actually actively creating that market, as you said, which helium's not. So helium's just going to come a gutser. the wheel's going to fall off that Billy cart, guaranteed.
I think that power thing's a dumb thing too. I mean, like, all of these are like really dumb things anyways, because like they're all using this very complex method to then just basically a spreadsheet, right? That's always like the joke about cryptocurrency is like, why isn't that just a spreadsheet or Web3 or whatever?
It's a ledger. Yeah, it's basically a ledger. Yeah.
It's a spreadsheet.
It's a ledger, how you can trade.
Anywho, I send all of your hate mail to blockchain at theampower.com. That'll go directly into where I keep my cryptocurrency, which is the toilet.
I, on the other hand, will happily accept crypto donations. Thank you very much. I accept library credits. I accept power credits as well. I accept everything.
The toilet is also known as the most recent price on most cryptocurrencies, as in they are in the toilet. So
really, I could have sworn that my portfolio is massively positive. I'm sorry to tell you, but I could have sworn.
Good for you, buddy.
Just saying. Just saying.
All right.
Anyway. All right. Well, that's all we got for this week.
Well, I'm going to go and do something poor people do, and Dave's going to go and do something rich people do
That's right. Yep.
Yeah. All right. Chat with you next week.
Catch you next time.